meeting. All attendees are in listen-only mode.
Well, hello everyone. Welcome to our coaching clinic for drug calculations using fractional equations. We are excited to give you this opportunity to review this method for solving drug calculation problems. We hope it'll be helpful to you and an adjunct to using the formulas that are presented to you in Nurse Achieve. So let's get started. This presentation focuses on fractional equations method for solving math problems and allows you to use the same process for each step of a problem and can be helpful in ensuring you did not miss a step. Many drug calculation problems can be solved by memorizing a few specific formulas, and these do allow for conversion of units, elimination of common units, and results in the desired units. Formulas require fewer steps than the fractional equation method. And these formulas are presented to you in the Nurse Achieve platform under the Pharmacology tab in the Drug Calculations sections. And though formulas do require fewer steps, they also require memorization. And if you're not good at this, the method we're about to present to you will demonstrate that you can solve problems without having to memorize the formulas. You can use this method also to check your work, even if you do use the formulas to verify you did your math correctly. All right, let's talk about the basic rule of an equation. When you're looking at a formula, all of your mathematical computation is on one side of your equation, and your unknown element is on the other side of the equation. So you already have your equality set up in a way that allows you to just simply solve the formula on the one side of the equality to get the solution. However, in this method, that is not going to be the case. So you have to remember these basic rules to equations to make sure you're doing things correctly. So for a mathematical expression to be an equation, there must, first of all, be an equal sign. And whatever is on the left side of the equal sign must be the same as or equal to what is on the right side of the equal sign. Additionally, when solving for an unknown element, whatever is done mathematically on one side of that equal sign has to also be done on the other side to maintain that equality. Okay, so anything I add to or take away from has to be done on both sides of the equality. Now, with a formula, you're already set up so that all you're doing is the math that needs to be done on the one side to get the final answer. However, with this process that we're about to use, you're going to be moving things from one side to another or eliminating something from one side or the other. And so to maintain the equality, you have to do it to the other side as well. And so unknown numerical elements will be assigned a letter designation, typically X, Y, or Z, or A, B, or C, depending on however many unknown elements there are. And then additionally, drug calculations typically will have only one unknown element per step, but formulas might have more than one, just depending on how they're set up. Usually, though, with a drug calculation, per step, you're going to have only one unknown element. All right, so here's our rule of equality. A linear equation example would be 2 plus 2 is equal to 1 plus 3. Right? Those are the same on both sides of the equality and solves as 4 is equal to 4. With one element given as an unknown, such as x, we get 2 plus 2 is equal to x plus 3. Now it could be 2 plus x is equal to 1 plus 3, or 2 plus 2 is equal to 1 plus x, right? You could have done that in any way where your unknown is whichever element you chose. But for our example, we made the 1 the unknown element. So that makes our equation look like this. 2 plus 2 is equal to x plus 3. And when we solve it, we get 4 is equal to x plus 3. Right? So this is what we mean when we talk about having to do to one side what you do to the other side, because we don't have what is our x actually, right? We don't have what is that number that should go where the x is at this point in the game. So we have to get there. And in order to get there, in this particular equation, we have to get rid of that plus 3. So how am I going to get rid of that plus 3? Well, if I want to get rid of it, that means it has to be equal to 0. So to get a positive 3 to 0, I have to put in a negative 3, right? So my equation now becomes 2 plus 2 is equal to x plus 3, minus 3. But to do that, I have to also minus 3 on the other side, right? So if I solve for x, I end up with my 2 plus 2 is equal to 4, so that 4 is equal to x plus 3. But to get rid of this plus 3, I have to subtract it. So if I subtract it on this side of the equation, I have to subtract it on this side of the equation. So now I have 4 minus 3 is equal to x plus 3 minus 3. Okay, so 1 is now equal to x. So I hope this is clear. I know that's a little bit complicated just listening to it. You have to really kind of see it on the screen. So if you're doing an audio here where you're paying attention to something else as well, please take a moment to look at this slide, because our 2 plus 2 is equal to x plus 3 became 4 is equal to x plus 3. To get rid of the plus 3, I have to subtract. So I end up with 4 minus 3 is equal to x plus 3 minus 3. To get rid of that 3 that's on my x side, I have to do it to both sides. And so I end up with a solution then that is 1 is equal to x, because 4 minus 3 is 1, and 3 minus 3 is 0, so x plus 0 is x, right? So that's how we get there. A fractional equation example would be, for example, one that we do all the time, which is how much does a patient weigh in kilograms when the weight is given in pounds. So a patient weighs 25 pounds. How many kilograms do they weigh? Well, we know that 1 kilogram is equal to 2.2 pounds. So we can set up a fraction using this knowledge. So 1 kilogram is to 2.2 pounds as x kilograms, what we don't know, is to 25 pounds, what we do know. And when we cross multiply, we get 25 is equal to 2.2 times x. So to get my x by itself, then I have to divide by 2.2 to get rid of it, right? So if I'm going to divide by 2.2 on this right-hand side of my equation, I have to also divide by 2.2 on the left-hand side of my equation. So I end up with 25 divided by 2.2 is equal to 2.2 divided by 2.2 times x. And when I solve that problem, I end up with 11.36 repeated to is equal to x, right? So that's where I get, and then I round my math to 2 decimal places. I get 11.36 kilograms is equal to x. So 25 pounds is equal to 11.36 kilograms. That's how I get there. So we're going to look at this again, a different problem to kind of let you see how we walk through this. All right, using a basic dose calculation. On hand is 40 milliequivalents of some medication in 100 milliliters of normal saline. My order says to give 30 milliequivalents. So how many milliliters will that be? I can set up my equation. 40 milliequivalents is to 100 milliliters as 30 milliequivalents is to x milliliters. Okay, so what I know here and what I need to know here, setting them equal, I can then cross multiply and get 40x is equal to 3,000. And when I divide both sides by 40 to get x by itself, okay, 40 divided by 40 times x is equal to 3,000 divided by 40. So x is equal to 75 milliliters. Okay, so another conversion that you'll frequently do is household measures to metric. In the United States, most people use household measures for their daily life and metric only for very specific, work-related stuff like in healthcare. So when a patient comes into the ER and they say, how much Tylenol have you been taking or giving to your child for their fever, they'll say something like 1 teaspoon or 2 teaspoons every 4 hours. So you have to know how many milliliters is in that teaspoon in order to document it correctly. So we're using an example here of the patient's been getting 5 teaspoons of something. And we need to know how many milliliters that is. Well, I know that 1 teaspoon is 5 milliliters. So if I set up my equation, 1 teaspoon is to 5 milliliters as 5 teaspoons is to x milliliters. Then I can cross multiply and I get x is equal to 25 milliliters. It's a very straightforward process once you really understand what you're setting equal to what. Okay. All right, so some things to remember. When you're looking at formulas, the line that is used is read as a per symbol or as a division operator, right? So the right side of an equation in a formula is typically what you're solving for, the answer you want. The x is by itself already. When you're using fractional equations, the x is not by itself already, so you have to get it by itself. That's why that rule of equality matters, okay? With your formula, you've already done that part, right? It's already given to you that way. But if you don't use the formula, you have to get there. So that's why all of that pre-stuff that we just did is important. And so when you're looking at a formula and you see that line, you're going to either be reading that as a division symbol divided by or a per symbol. So for example, 5 milligrams is to 10, or, is 5 milligrams per 10 milliliters, right? It's read as 5 milligrams per 10 milliliters. And then how many milliliters is in 15 milligrams, right? Well, if you use a formula that desired over have, right? I desire 15 milligrams, I have 5 milligrams, I multiply it by my units of measure, which is milliliters, right? So it's read as 15 divided by 5 times 10. Okay, so this is how the formula is written. This is the desired over have formula, which is different, right? In this case, you have milligrams on the top and the bottom, and then your milliliters is to the side, right? It's a different setup. With our fractional equations, you're going to use the same unit of measure in the same line, right? So in this case, if I drew a line here, I can do 15 times 10 is 150 divided by 5, right? I would still get the same answer as 15 divided by 5 times 10, right? So either way, it's going to come out with the same answer. But my milligrams and milliliters are at the top, and I have milligrams on the bottom. And in your fractional equations, it's the other way around, right? In the fractional equations, the line means is to, and the equal sign is read as. So like I have been saying in these other problems that we've already done, 5 milligrams is to 10 milliliters as 15 milligrams is to X milliliters. So I've written it here. Notice my milligrams are both on the top here, and my units of measure, the milliliters, are both on the bottom. And it's different than the formula. So making sure that you're ready, you're able to read that, okay? All right. Next thing is we need to think about questions. What am I trying to do in my problem? Am I converting weight? What am I trying to calculate? And what am I starting with, right? So if I'm converting weight, 2.2 pounds is equal to 1 kilogram. If I start with kilograms, I'm going to multiply to get pounds. But typically your problems are going to give you pounds, and you're going to need to divide by 2.2 to get kilograms. This is one of those that I did have trouble remembering because I have problems with formulas. And so I was always writing it out. And my mnemonic to help me is that pounds is more than kilograms. That's all I could do. Pounds is a bigger number. I want to live in the UK because then I weigh less, right? My number is smaller in the UK than it is in the US, right? So that was what I used to do, how I helped myself stay straight with that. All right, what am I trying to calculate? The number of tablets, the quantity in milligrams or milliliters or grams, the quantity per day or per dose, and the infusion rate in milliliters per hour or drops per minute. And then what am I starting with? What do I know? Amount per kilogram, the number of doses, the amount on hand. For example, milligrams per milliliter or milligrams per tab or amount in solution, right? Which of those do I know? All right, and again, that pounds divided by 2.2 is equal to your kilograms. This is going to be a big thing. Most of your problems will give you a weight in pounds that you'll have to convert, okay? All right, so here's a weight conversion and daily dose calculation. Order is to give medication of 2 milligrams per kilogram daily for a child weighing 110 pounds. What is that daily dose? Well, First, I got to convert that weight. So 2.2 pounds is to 1 kilogram as 110 pounds is to X kilograms. I cross multiply, I make my equation, right? 2.2X is equal to 110. I solve for X. Dividing both sides by 2.2 gives me X is equal to 50 kilograms. Okay. So now we can determine that daily dose. 2 milligrams for each kilogram. 2 milligrams is to 1 kilogram as X milligrams is to 50 kilograms. Cross multiply. Get your equation. Oops, sorry. And then solve that equation, right? 1X is equal to 2 times 50, so X is equal to 100 milligrams. That's my daily dose. Now, let's say the doctor says, oh, you know what? We're going to give that daily dose, but now I want to give it in 3 divided doses. Okay, so what is my single dose? I'm going to round to 1 decimal place. So first we're going to convert weight and calculate the daily dose just like we did on that previous slide. And then based on those calculations, we already know the total dose is 100 milligrams, but we want to give it in 3 doses. So we have to set up our equation. We know that 100 milligrams equals 3 doses for the total of 1 day. And what we want to know is how many milligrams in 1 dose. Therefore, 100 milligrams is to 3 doses as X milligrams is to 1 dose. Cross multiply, I get 3X is equal to 100, and then dividing both sides by 3, I get X is equal to 100 divided by 3, which is equal to 33.33 repeating, and so rounding to 1 decimal place, I get 33.3. All right, here's another one completely doing the whole thing. 8 milligrams per kilogram daily to be in 4 divided doses for a child weighing 27 pounds, 8 ounces. And what we have on hand is 2 milligrams per milliliter. What is a single dose? Write your answer to 1 decimal place. So remember our questions. We have to write out those answers. Do I need to calculate weight? Yes. What am I trying to get? A single dose. But first I know I have to get the daily dose, right, to get me to the single dose. So it's 2 steps here. And then what am I starting with? What do I know? I know the patient's weight, but it's in pounds and ounces. I know how much I need to give, 8 milligrams per kilogram in 4 different doses, so divided by 4. And then I know what's on hand, 2 milligrams in 1 milliliter. Okay. So the physician order, we have it here. First thing we're going to do is convert that weight, but you have to know your conversions of household measures to metric system, right? There's a little tremor here that can happen because of this, right? So know your conversion of ounces to pounds, right? So even though you're converting from household measure to metric measure, within household measure there are conversions, right? And this is an instance of that. 1 pound is equal to 16 ounces. So 8 ounces is equal to half a pound. Okay, so it's going to be 27 pounds, 8 ounces is equal to 27.5 pounds, not 27.8, right? This is where people typically get tripped up when they're giving you household measure in pounds and ounces. Okay, remember this is not tenths of a decimal point, right? This is percentage of 16. So you have to figure it out from that perspective. So our 27 pounds and 8 ounces is actually 27.5 pounds. So we're going to convert that to kilograms. 1 is to 2.2 as X is to 27.5. And I end up with 12.5 kilograms, right? Patient weighs 12.5 kilograms. Then I'm going to try to get my daily dose. Well, I know I need to give 8 milligrams per kilogram. So how many milligrams is that for 12.5 kilograms? I cross multiply, I solve my equation, I get 100 milligrams for my daily dose. Right? And then my daily dose I need to give in 4 doses. So 100 milligrams is to 4 doses as how many milligrams is to 1 dose? When I cross multiply, 100 is equal to 4x divided by 4 on both sides. I get 4x, or I get x is equal to 100 divided by 4, so x is equal to 25 milligrams per dose. Okay. All right. Now I have to figure out how many milliliters is that. I need to give 25 milligrams, but what I have on hand is 2 milligrams in 1 milliliter. Right? So now I have to get to milliliters. So you can see why this is a longer process, because you're doing it step by step by step, whereas your formula has you doing it all in one fell swoop. But you've got to make sure in a formula you know what numbers to put where. Okay. Here you're doing it step by step, so you're only focusing on one thing at a time. So 2 milligrams is to 1 milliliter, 25 milligrams is to X milliliters. When I cross multiply, 25 is equal to 2X, and then dividing by 2 on both sides, I get 12.5 milliliters is equal to X, right? So the actual dose I'm going to be giving is 25 milliliters, right? That's how I get my 8 milligrams per kilogram in 4 divided doses. Each dose will be 12.5 milliliters because of what I have on hand. Okay. All right, here are 3 practice questions for you to work through on your own. The solutions are on the handout that's attached to this webinar that you can download. Please do this on your own time and enjoy, solving these problems using this method, because it will give you that very logical step-by-step process and make you feel, I think, in many cases, very accomplished, right, for solving it step by step. Okay. Metric conversions, remember, it's really important to know which way you're going, right? Basically, to go from a larger unit of measure to a smaller, you're multiplying. To go from smaller to larger, you're going to divide. If the unit is smaller that you're trying to get to, your number is going to be larger. If your unit is larger that you're trying to get to, then your number is going to be smaller. Okay? They work backwards from each other. Okay? So remember, 1 liter is 1,000 milliliters, 1 kilogram is 1,000 grams, 1 gram is 1,000 milligrams, 1 milligram is 1,000 micrograms. So here are some examples. 2.5 milliliter or liters is how many milliliters? 6 kilograms is how many milligrams? 50 milliliters is how many liters? 5 grams is how many milligrams? And 700 micrograms is how many grams. So pause the video here in order to solve this metric conversions for yourselves. And then once you've solved them, you can come back and do these reveal answers, right? So pause your video now. And then let's come back. And here are your answer choices or answer solutions to each of these problems, right? So if you didn't get these, then that means you went either in the wrong direction or you didn't move enough decimal places. Those are typically the 2 things that trip people up, right? Remember, we're going to go from a larger unit of measure to a smaller unit of measure, right? So we're going to multiply. The number is bigger, the units are going to be smaller. Okay, the units are going to be smaller, so my number is going to be bigger. So 2.5 becomes 2,500. Here, my unit is going to be smaller, so the number I get needs to be bigger. And in this case, it's 1,000, right? Kilograms down to grams, and then grams down to milligrams. So that's how I get 6 million milligrams. 50 milliliters to liters. My unit is getting larger, my number is going to get smaller. And I left the terminal 0 on because of so you could see the decimal place movement, but normally when you write these, you don't use the trailing zeros in the right-hand side of the decimal place. So you would actually write this as 0.05, and that would be your answer, right? Here we're going from grams to milligrams. So straight up, getting a smaller unit of measure, the number will be larger, 5,000 milligrams. And then 700 micrograms to grams. Remember, micrograms is going to go to milligrams, is going to go to grams. So that's 1,000, but going in the opposite direction, right? So from 700, 1,000 is 0.7, and then another 1,000 is 0.0007. Okay. All right, types of infusion problems, typically milliliters per hour. or milliliters per hour to be infused over less than an hour or sometimes more than an hour, and then drops per minute. Remember that milliliters per hour can be infused via a pump or a flow control device like a dial-a-flow that's inline. But drops per minute is a straight roller clamp control administration. Again, what am I calculating? Am I looking at rate or volume or milliliters or drops? And is my rate given to me in minutes or hours, and how do I need to calculate it? Remembering that a half an hour, 30 minutes, a quarter of an hour, 15 minutes. Okay. All right, basic calculation. A patient is to receive 15 milligrams of Dilantin in 100 milliliters of normal saline to be infused over 30 minutes twice daily. What is my rate of administration in milliliters per hour? I want to give this dose in 30 minutes. So how much or how fast or what rate would I use for an hourly administration rate? Okay. If I'm giving 100 milliliters in 30 minutes, then how many milliliters would I be giving in 60 minutes? That's my hourly rate. So cross multiplying, 6,000 equals 30x, dividing both sides by 30, I get x is equal to 200 milliliters in 60 minutes. Now, I'm not giving the patient 200 milliliters. This is the rate of my administration, not my dose. Okay, my dose is 15 milligrams in 30 minutes. That's the 100 milliliters. Okay, but I'm going to give it at 200 milliliters per hour to get it infused at the right rate. So 200 milliliters per 60 minutes or 200 milliliters per hour. This is the rate we set the pump. We also set the volume to be infused at 100 milliliters. This makes the infusion pump stop in 30 minutes at 100 milliliters, right? That's what I want to give. That's my dose. This is how fast is it going in, okay? All right, so now I have a patient to receive 15 milligrams of Dilantin IV piggyback over 1 hour. On hand is 60 milligrams in 500 milliliters of normal saline. What rate should the pump be set for? Well, if I was going to give 60 milligrams in an hour, I would set it at 500 milliliters per hour. But I'm not giving 60. I'm giving 15 in an hour. So if I'm going to only give 1/4 of this in an hour, then I can do 1/4 of this in an hour. So it's a simple math here, right? 60 divided by 4 is 15. 500 divided by 4 is 125. I can just do that as a straightforward math, right? I know that 60 milligrams is in 500, and if I give it in 1 hour, that's going to be 500 milliliters per hour. But I'm not giving that much. I'm giving a quarter of that. So if I divide it by 4, I get 125 milliliters to give the 15 milligrams in 1 hour. So it's a simple, straightforward math. Sometimes it's just logic. You can do that in your head. That's okay. But occasionally, it's not going to be that way, right? You might get an order where it's like, okay, I'm not really sure about that math, right? So that's why this process works so great, because if you're not sure about that math, if it's not straightforward, like, oh, it's a fourth and a fourth, right? I can do that. Then you have to set up your equation. And so you end up with 60 milligrams is to 500 milliliters, as 10 milligrams is to X milliliters. Okay, this is going to be a little bit different. So when I do my math, when I cross multiply, I get 5,000 is equal to 60X. And when I solve for X, divide both sides by 60. So 5,000 divided by 60 becomes 83 with 3 repeating. And so rounding to the nearest whole number, I'm going to get 83 milliliters per hour. So if I wanted to use this bag of Dilantin that has 60 milligrams and 500 milliliters of normal saline, that's what I'm hanging up on my line, but I only want to give 10 milligrams, the rate of my infusion is 83 milliliters per hour. Okay? That's how I get there. So I know that I'm giving the right amount, because in 1 hour, it's going to stop. I'm going to set it for 83 milliliters per hour, and I'm going to have it volume to be infused is going to be, the 83 milliliters. And that's it. It's going to stop in 1 hour. Okay, because I know that that's my 10 milligrams. All right. So if I have to give it in less than an hour, a patient is to receive 20 milligrams of Lasix twice daily to be infused over 15 minutes. On hand is 60 milligrams in 30 milliliters. What's my rate per hour? Well, I know I have 60 and 300, but I want to give 20 in 15. So start with what we know and then determine what we want to give. So if I have 60 and 300, but I want to give 20, how much am I going to give? How many milliliters? I cross multiply. I get 60 times X is equal to 20 times 300, so 60X equals 6,000. And then I divide by 60 on both sides to get X is equal to 100 milliliters. So this is my 100 milliliters is how much fluid I want to give my 20 milligrams. But I want this 100 milliliters to go in 15 minutes. So if there's 60 milligrams and 300 milliliters and there's 20 milligrams and 100 milliliters that I need to give in 15 minutes, but I need an hourly rate because I got to set a pump, right? And it doesn't do 15-minute infusions. I have to set an hourly rate. So I know that to get that milliliters per hour, I need to convert my minutes to 60 to get the 1 hour. So 100 milliliters in 15 minutes is equal to X milliliters in 60 minutes. When I cross multiply and I solve my equation, I end up with 400 milliliters per hour, right? 400 milliliters in 60 minutes because 100 times 60 is equal to 15 times X. Divide by, or when I multiply it out, I get 15X is equal to 6,000. Then I divide both sides by 15. X is equal to 6,000 divided by 15. That's 400 milliliters in 60 minutes or 400 milliliters per hour. So I can take this bag of fluid and set it up at 400 milliliters per hour. And in 15 minutes, the patient will have gotten what they need, the 100 milliliters, right, which is 20 milligrams. So the part of the reason why we recorded this is so that you guys can take the time you need. Pause the video, look at this, make sure it makes sense to you, okay? Because if it's not making sense to you, you can reach out to your instructor. We'll be happy to walk you through this individually or on a group Zoom coaching call, however we need to do it so that it makes sense to you. Especially if you have trouble with formulas, this is going to be your method to make sure you're doing your math right, okay? All right, so now let's do another infusion. There's a pandemic. There's no IV pumps and there's no inline regulators available. You've got to calculate drops per minute. And this can happen in the U.S. Even in the U.S., right? We have tornadoes, we have hurricanes, we have other natural disasters, things get struck by lightning, earthquakes, all kinds of stuff can happen, knock out the electricity. You don't have any of this stuff and a shortage on supplies. So you're doing drops per minute, all right? An order is received to give 250 milligrams of ampicillin in 500 milliliters of normal saline over 2 hours. The infusion set gives 15 drops per milliliter. How many drops per minute will be infused? Round to the nearest whole number. All right, what do I know? I know I have 250 milligrams in 500 that I want to give over 2 hours. 1 hour is equal to 60 minutes, and 30 drops is equal to a milliliter. All right, let's get there. If 1 hour is equal to 60 minutes, then 2 hours is going to be equal to 120 minutes, right? If I can give 500 milliliters in 120 minutes, how many milliliters would I give in 1 minute? Right, you see I'm getting there. First, I had to figure out how many minutes is my total infusion of 250 milligrams and 500 milliliters. So 500 milliliters in 2 hours, which is 120 minutes. But I need to get to drops per minute. So if I'm going to give 500 in 120 minutes, how many milliliters will I give in 1 minute? When I do that math, cross multiply my 500 times 1 is equal to 120 times X. Right? Then I end up with X is equal to 500 divided by 120. So X is equal to 4.166 repeating milliliters per minute. Right? 500 in 120 minutes is equal to 4.16667 milliliters per minute and, milliliters in 1 minute, right? So this is my 1 minute rate, but I need drops. This is milliliters. So if there's this many milliliters, right, that need to be given in 1 minute, and what I know is that I have 15 drops in 1 milliliter, I can set up my equation. 15 drops is to 1 milliliter as the unknown number X drops is to 4.166667 milliliters. And when I cross multiply, I get X is equal to 62.5 drops. That's what it comes out to. And then rounding to my nearest whole number, because you can't give half a drop, right? I get 63 drops per minute. So again, use this video, go back, look at slides, walk yourself through it, make sure you understand it. Here are some other infusion problems for you to practice. There are also infusion problems on the www.registerednursing.org website that you can look up under pharmacology, under infusion problems, on Quizlet.org. There are many YouTube videos that have infusion problems for you to practice. So there's lots of stuff out there for you to do, as well as in the NurseAchieve platform. Right, so use whatever is available to you, practice these drug calculations so that you feel comfortable and confident in using either the formulas or this method of step-by-step to solve for whatever is your unknown at each step of the way. Okay, and this will walk you through it. I hope this has been helpful to you. If you have any questions, again, don't hesitate to reach out to your instructor. We're happy to give you individual or group coaching via Zoom as needed so that you can be successful. That's our goal. And thank you so much for your time and your attention today.